all day long. Look, I wrote calculus down in the right-hand corner. There it is. That's the key to calculus. It's the everything. Well, maybe not everything, a little tricky too, but let's go. We're just going to talk about one type of problem. Just one. There it is. That type of problem. This type of problem. Now remember, we want to create polynomials. We don't want fractions. We have a tactic in the next section. We're going to talk about a quotient rule. Quotient, meaning a function up top and a function down below. I look at this and there's no way in hell I think this is a quotient. We're still in power rule, so there must be some algebraic trick. What if we were to have this? I'm just going to go off the side, different topic. Just, we're going to get weird. I'm going to say 7/3 plus 2/3 minus 1/3. Now, when we write fractions, it's all that common denominator stuff, huh? So we get 7 plus 2 minus 1, right? That's how we would do it. But wait, can we think about it going this direction? So if you were to have the 7 plus a 2 minus a 1, a 7 minus a 2 plus a 1 or something like that, you could actually break it up and go the other direction. So you can put the denominator underneath each individual term. And that's the trick here. I mean, if you want to get weird, I see some students write that it's x to the negative first and then they multiply it in. Go for that. It's all good. But we're going to write it out. We have all this. Bruh. Put an x underneath it. Put an x underneath it. Let's go. Breaking it up. That's how you add. That's the opposite of the way you add fractions. Now, what we're having in here, 4 minus 1 is 3, so you get your x cubed. Don't lose sight of that when fractions come into it. We get the 5 and then x squared over x. We're like, we all have that one. It's x because 2 minus 1 is 1. And then here we're going to write it down as 2x to the negative first. Algebra's done. Rely on your algebra. Rely on the algebra. Make the calculus simple. And now we can go find y prime. Or I want to write dy dx. That's a valid way. So our 3 falls to the front, and we're going to lose a power. So we get 3x squared. The slope of the line, negative 5x, is negative 5, so that's what we get there. Our negative 1 is going to fall to the front. It's going to change that to a negative 2. We get negative 2x to the, what's negative 1 minus 1? Negative 1 minus 1? That's negative 2. So this, I like this answer. I think that one's pretty freaking dope. I would keep it, but I don't know. It's not too bad to go through and be like, hey, I don't like my negative exponents. So we write it as such. The negative 2 doesn't go down to the bottom with it, right? The power's on the x. Cool. Love this game. When you see something of this form, but it's not really of this form, it's when you have this single term in the bottom. You can play this game. Make your life easier. The game you can't play, if this was an x plus 2, no, don't play that shit. Don't do it. Don't break it up. If there's 2 terms, that's 2 terms in the denominator, you don't play that game. You do like long division. You do other freaking games. No, don't break it up like I just did. I mean, there's ways and tricks and stuff. Don't do that though, huh? Let's do another one. It's just one type of problem in this one. There it is. Bang! Like, that's a good test problem. Like, I look at that and be like, yeah, I would love that on a test. I think that's an excellent form of a problem. I love this trick, and I never leave this trick off of exams. But I like messing with the idea that you all need to get good with your rational exponents. So let's go through first, and let's just start cleaning some stuff up. Like, let's rewrite this numerator, huh? The 3x to the 5th is solid. We don't have any issue. Jeez. Minus our 4, and now we're going to write that. So the power is the numerator, so 2, and then the root, that's the denominator, 3. And then plus that number, pi. And now we're going to do the same trick. We're going to put the square root of x underneath all the terms. But don't write the square root of x, write to the 1/2. To the 1/2. And x to the 1/2. Beautiful. Now we just have to use the rules of subtractions here. So our f of x is going to be equal to, and I'm kind of going the long way about this. I'm going to say 5 minus 1/2, because that's how that's going to work. And we get minus 4 times, and that's x to the 2/3 minus 1/2. And then plus, this is going to be pi times x to the 0th minus 1/2, because there's an x to the 0th up there. Did you know that? What's anything raised to the 0th power other than 0? 1. Neat. Sorry, I'll get rid of that. So the x to the negative 1/2. Keep going, keep going, keep going. And now we just have to do some subtractions. I'm going to assume you know how to subtract fractions. So I'm just going to run through. 10 halves minus 1/2 is 9 halves. 2/3 minus 1/2 is 1/6. And this is already ready to go. Now this is what we call derivative rate. F prime of x. Let's go. The 9 halves falls to the front. You're going to get 3 times 9 halves. X to the 1, 9 halves minus 1 is 7 halves. We're going to say 4 times, and that 1/6 is going to fall to the front. We're going to have to subtract 1, and that's going to become negative 5/6. Next, we're going to get our negative 1/2 is going to fall. That's going to change this to a minus, and we get our pi over 2. I like that. Negative 1/2 minus 1, that's negative 3 halves. Let's clean it up, because that is not... I don't mind if you leave negative exponents. I don't care if you leave rational exponents, but do not leave shit like that sitting next to it. You got to put it all together. That's just sheer laziness. You leave that not cleaned up. So we're going to get 27 halves, x to the 7 halves power. Minus 4 over 6, my pet peeve. I don't like even numbers over even numbers. It's just sheer laziness, and it drives me nuts. So don't leave evens over evens. I'm a total dick about it, huh? Then we get this last part. And I think this is great. I think this is a terrific answer. However, I'm going to write it without the rational exponents as well. We're going to clean it up. I'm going to get rid of all the negative exponents. I'm going to put the stuff where it goes. It's not a terrible thing to know what this stuff is. So 27 halves, 13.5. That's an acceptable decimal. If you wrote 13.5 there, sure, it's exact. But still, screw decimals. Screw decimals. Your homework, you have some. Good for you. It's fun shit. So we're going to get 2 over 3 times. And this is going to be x to the 5th and the 6th root minus pi over 2 times the square root of x cubed. There's another one that we could have looked at. So these algebra things, like here, I hope you've noticed throughout your power rule stuff, it's not about learning how to do the power rule. It's about getting as many. Of course, you got to learn your power rule, but we're flexing them algebra muscles, trying to remember the stuff that we've maybe left behind, or maybe we're learning something that's all new, and you're like, I've never seen some of this shit. Cool, let's learn it. You still have questions on these things, and you're not 100% sure, and there's algebra stuff that's prerequisite stuff. You need to let your teacher know. You need to let your past peer know. Let somebody know. Be like, I need a little bit of help. It's not weakness. That's not weakness. That's using your frickin' head. That's using your resources. Use your frickin' resources. Huh? I got your back. If you're willing to work, I got your back. Past peers, got your back. But you gotta ask. I can't help you. I can't have your back unless you ask for help. So, do it to us. You got algebra problems, trig problems, calculus problems, you come to me with your frickin' problems. I don't know if I can help. We'll see. But